Welcome everybody. Let's continue our journey of precalculus. So for the fundamentals, we need to be solid with certain equations and what their graphs look like for these equations. So just by definition, an equation is a mathematical sentence that includes an equal sign, right? So in this class, we will just focus on one or two variables, usually using x or y. So the game plan is I am sure you have probably seen some of these equations and functions. The game plan is to get a better understanding of what they are and what do they look like on a graph. So let's take a look at the first function. We have y equals x. And if I were to say, hey, what does this graph look like? Y equals x. Can you pause the video and draw what you think this graph will look like? Right. Okay, so let's say you pause the video and you have an assumption of what it looks like. This will be our graph. That if this is our x-axis and this is our y-axis, if I have y equals x, it'll look just a diagonal line just like this. If I had y equals negative x, then the graph would look something like that, right? It would be the other way around, okay? And the question we should always ask ourselves is why? Why does a graph, wait, let me get this over here. Why does y equals x, why does it look like a graph like this? Okay, and the idea is we're just plugging in values. So let's say if we have our x values and we want to plug it into the function, right? This is y equals, or f of x equals x, right? Or y equals x, right? The idea is we're just plugging in values of x into the function. So let's start at 0, because 0 is a nice number for us. If we just say x is 0, and then if y, we're going to say f of 0. If I plug in 0 for x, I just get 0. If I plug in f of 1, I'm just plugging in 1 where the x is, and I get 1. So notice these are my points. So plug in 2, I get 2. Plug in 3, I get 3. And same idea. Negative 1, negative 2, negative 3, right? So then the graph will just, like if we have here, the first point will be 0, 0. So that point would be here. Then let's take a look at 1. When my x value is 1, right? When my x value is 1, the y value is 1. So where is that point? 1, 1, it's right here. Then I have 2, 2, 3, 3, and so on and so forth. And the same thing happens with negative values. I have negative 1, which is here. Negative 2, negative 2, negative 3, negative 3, and then you have this diagonal line just like that. And it looks a little sloppy here, and it could have been connected better, but the idea is this is the line. Okay, great. All right, let's look at the next graph. So we did y equals x. Let's take a look at y equals x squared. So if I said, hey, what does y equals x squared? How does this graph look like? Pause the video, and what do you think it looks like? And if you're really good, try and think to yourself, why does it look the way you think it looks like? Okay. Alright, so let's say you paused the video and you thought about it. The graph of y equals x squared should just look like this. Some quadratic function, it'll have this parabolic feature. Okay. And let us just explore very quickly why, let me move this here, put this over here. Why does x squared look like this, right? So if you want, take your time, pause the video, plug in the values of x into this function. What y values do you get? Plug in the points and see for yourself that you should get this shape. Right? So let's say if I wanted to, right, let's do it together. So let's say if I say, what is f of 0? Well, this is just 0 squared, so that's just 0. What about f of 1? Well, this is 1 squared, so that's 1. This is f of 2 is 2 squared, so that's 4. 3 squared, that's 9. So notice that these are the points we have. So let's say the first point is 0, 0 is right here. Then I have 1, 1 is here. Then I have 2, 4 is here. 3, 9 is here. What do you think the next one would be? 4, 16, right? It would look something like this over here. And we're going to connect the graph, we're going to connect the points in some curve like this. And you're going to notice that if you do it for the negative values as well, like if I have negative 1 squared, that is positive 1. Negative 2 squared, that is positive 4, and so on. And you're going to see that if you graph the points, it'll have some feature just like this. Oh god, that wasn't, there you go, a little bit better. Okay, so that is y equals x squared. Fantastic, let's move on. Here, this function, I hope you've learned it, and if you haven't, it's not the end of the world. If I were to say, hey, what does this graph look like? Y equals, and the way you read it is absolute value x. And what does it mean to take the absolute value of a function? Like, what does this function do? Pause the video and think about it, and try and create a sentence that depicts what this function does. And what do you think the graph looks like? Right, so if you want to see how it looks like, it should look like this. Some V-ish shape, just like that. And let's just quickly go over this function. I have my paper to use. So before I even explain why does this graph look like this V-ish shape, let's write in one sentence what does it mean to actually take the absolute value of a function. So absolute value, we are taking the distance of a number to 0. Okay, that's what we're doing. So let's, for example, let's say if I have the number line over here, this is 0, I have my positive numbers here, my negative numbers here. If I say, hey, what is the absolute value of 5? Well, okay, I go to 5, right? And the question I ask myself is, what is the distance from 5 to 0? How much distance is this? It's not a trick question, it's just 5. It's just 5. I could say that for any number. If I say absolute value of 10, I go to 10, which is over here. What is the distance from 10 to 0? It's 10. But what happens if you take the absolute value of a negative number, let's say negative 7? Well, if I go to negative 7, it's 1, 2, 3, 4, 5, 6. This is negative 7 is over here. What is the absolute value of negative 7? Well, you're taking the distance from negative 7 to 0, right? What is this distance? It's 7. Distance is always positive. So then here, this is 7. So you could think that, I mean, I'm pretty sure maybe some of you have thought, oh, it's just, it makes any value positive, which is true, but technically you're taking the distance. That's why your values will always be positive, because you're taking the distance from a number to 0. So if I say, what is the absolute value of negative 100? It's 100. And that's the idea. So let's take a look at plugging in the values in here into this function so we could see why it creates this visual. If I say, hey, what's the absolute value of 0? Well, if this is 0, what is the distance from 0 to 0? It's 0. What is the absolute value of 1? Just 1. Absolute value of 2, 2, 3. What is the absolute value of negative 1? Right? It's just 1, 2, and 3. And if you were to plot these points, right, I have 0, 0. Let me zoom in a little bit. Let me zoom out. If I have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? La la la. And same thing with the negatives. It creates this V-ish shape. and that is our absolute value function. Great, let's move on. Next one, let's take a look at this one. This is a square root function. What I'd like you to do is pause the video, try and think, what does it look like? And in one sentence, what does it mean to take the square root of a number? What are you actually doing? Okay, let's see. This is what the graph looks like. It'll have this short curve like this. So let's examine the function real quick. Again, why does square root of x look like this? But in one sentence, we should write down, what does it mean to take the square root of a number? Ask yourself, what number times itself gives me x? So for example, if I said, hey, what's the square root of 0? What number times itself gives me 0? And that is 0, because 0 times 0 is 0. What is the square root of 1? 1, because 1 times 1 is 1. Square root of, let's say, notice how I skipped square root 2 and square root 3, because if I said, hey, what number times itself gives me square root 2, right? I'm sorry, what number times itself gives me 2, it's not a whole number. So remember that this number here and this number here, pause the video, what do we call these types of numbers? Irrational numbers, right? So for here, I skipped the irrational numbers, but the idea is what is the square root of 2? It's like 1.14, la 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 la. So then here the idea is square root of 4 is 2, square root of, and notice how I skip in between. Square root of 9 is 3, square root of 16 is 4, and these are our points. So we think to ourselves, if I look over here in the graph, my first point is 0, 0, which is right here. The next point is 1, 1. So 1, 1 is like here. Then I have 4, 2. And notice how like I'm going a lot this way, but I'm not going that much up this way, because this is 1, this is 2. So notice it's 4, 2. Then 9, 3. Then 16, 4. So the idea is it creates this graph. Like this graph, for the y values, it is going to positive infinity, but it's going at a very slow rate. And it has this, the idea is if you zoom out, the graph should look something like this. Okay, so that is a square root function. And now notice here, I wrote this question for us. What about negative values? So here, the idea is if I said, hey, what's the square root of 25? Pause the video, what is the square root of 25? It is 5, because 5 times 5 is 25. But what if I said, hey, what's the square root of negative 25? Can we do this using real numbers? Well, it can't be negative 5, because negative 5 times negative 5 is positive 25. So for now, does not exist for now. And you'll see that's why for this part of the graph, the x values that are negative are not included for this square root of x. But eventually, maybe using different types of numbers, maybe we can come back to this question. Okay. Very, very, very good. So we did square root of x. Here, for this graph, let's take a look. This is 1 over x. So here, this is a rational function where I have some sort of fraction. And for this graph, I'm going to show you what it looks. Well, if you know what it looks like, it's great. But for this topic, we're going to take some time in the future to actually go through this topic. So I'm not going to show you Why the graph looks like this, I'll show you what it looks like. Well, maybe we could express one certain part about it. Can x be 0? Can you have x be 0 here? Can you have 1 divided by 0? Nope, you're not allowed to have that. So it creates this vertical asymptote, and that's why the graph, that's a part of the reason why the graph looks like this. But we're not going to focus on this one today. I just wanted to show you how it looks like for you to have in your notes. And here is the type of graph I wanted us to look at. For this one, if I have x squared plus y squared equals 25, what does this graph look like? Pause the video. If you know what it looks like, draw it. If you don't, what will it look like? This will be a circle with a radius of 5. And the center of my circle will be 0, 0. So this is my center of my circle, and I go, let's say 1, 2, 3, 4, 5, bam, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I know I'm not going to draw the best looking circle, but it'll look something like that with a radius of 5. And the idea is we're going to explore this. If you want, and if you remember, ask me what this would look like. But okay, let's examine this. A circle with a radius of 5. Here, we'll come back to this in a second. This you could have in your notes. Very straightforward, very basic, but the idea is that if this is the Cartesian plane we're in, that this is the x-axis, or the horizontal axis is the y-axis, and just remember your quadrants, that here we start at quadrant 1, quadrant 2, quadrant 3, quadrant 4. And what is the reason why in mathematics we have like this labeled as our quadrants within these specific locations? Remind me when we do trigonometry. I will explain why. Okay. So each point in the plane is corresponded to an x comma y, right? Like every point is x comma y. And what does it mean for a pair x comma y to satisfy a given equation? So pause the video and think about that. For example, does this point satisfy this equation? So if you pause the video and you thought about it, does this point satisfy this equation? Well, let's see. This is my x value, this is my y value. So if y is equal to x squared, anywhere I see x, I could place 5. Anywhere I place 25, I'll put that for y. So does 25 equal 5 squared? And it's true. 25 equals 25, so check. So notice that this point satisfies this given equation. But if I had something like this, 5 comma 24, that would not, because I would have 24 is equal to 5 squared, and 24 does not equal 25. So notice that this point does not satisfy the equation, but this does. So that's what it just means to does a pair xy satisfy a given equation? All right, great. Let's move on. Here, this part we could skip for now. I'll show this in another lesson. Let's move to the juicy part. The juicy part is this right here, circles. So here, the definition of the circle, or the idea of it, is to consider the circle below. We're going to call the center h comma k. The radius of the circle is r, and a point on the circle is given as x comma y. So by definition, a point x comma y is on the circle if and only if its distance from the center h comma k is r. So what this is basically saying is you need the distance formula to create the equation of a circle, but for a point to be on the circle, so if I have a point on the circle, every point on the circle has to have the same radius. So if whatever this radius is, like if this radius is 5, then 5 units from here and all the way around, all of these points will satisfy the equation of that circle. And just for you to have in your notes, that distance formula. So notice that if I wanted to actually find the distance of the radius, right? If I want to find the distance of any 2 points on the plane, so like if I have, let's say, this point over here, let's say it's 2, 2, right? This point 2, 2, and this point over here, let's say -5, -8. How do I find the distance of these 2 points? You need to use a distance formula, right? And here, this Pythagorean theorem of a squared plus b squared equals c squared, this will be helpful for us, okay? And let's see, how much time? 21 minutes, we're almost done. So here, to create the equation of a given circle, it'll be this right here. So the idea is, if you square both sides, actually, let's ignore this part. Ignore this part. Here, please have this in your notes. Let's say the point xy lies on the circle of a radius r and the center h comma k if and only if x minus h squared plus y minus k squared is equal to r squared. This is the standard form of the equation of a circle. Okay, so what does that mean? Let's look at a certain problem, and hopefully this will help us understand the concept of this equation of a circle. Here, take a second, write this down, write this example down, and we'll do this question together. And it will help us understand the use of the distance formula and the equation of a circle. So take your time, have this down, and we'll do this question together. And then we'll be done. We'll be done with the lesson. Okay, so here, let's read it together. It's saying the point 3, 4 lies on the circle whose center is at -1, 2. Write the standard form of the equation of this circle. So let's be patient. Let's always, let's try and draw what on earth is going on over here. So let's take a look. It's saying that, let's say we have the plane over here. It's saying the point 3, 4 lies on the circle whose center is at -1, 2. So where is -1, 2? It is -1. This is -1 here. Like this is my x-axis, this is my y-axis, and this is 2. So we know that the center is right. Let me zoom in a little bit. The center is right over here. So this is my center, right? Center is at -1, 2. Okay, and now it's saying that the point 3, 4 lies on this circle. So where is this point 3, 4? 1, 2, 3. This is 1, 2, 3, 4. Right? This is 1, 3. 1, 2, 3. So then this is the point right here, and this point 3, 4 is on the circle. Okay. So the idea is, if this represents the radius of the circle, then the circle has to look something like this. Oh god, that was terrible. It should be a better looking circle. But the idea is this point over here, -1, 2 is the center, and this point over here, 3, 4, is a point on the circle. Okay, this is the visual of what we have. What the question is asking us, it's saying write the standard form of the equation of this circle. So if we know that the standard form is x minus h squared plus y minus k squared equals r squared, the idea is we want to create the equation of this circle. So how do you think we could do it? How do you think we could do it? Here, the first idea I'm thinking is, let's find the radius of this circle. Is it possible to find this distance of the circle? And yeah, because here we know that by using the distance formula, d is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. What this formula is telling us, give us any 2 points, we could find the distance of these 2 points. And the distance of these 2 points is the radius of the circle. So then how would you do that? If I know my center, like one of the points is, let me zoom in here. I know one of the points is -1, 2, and the other point is 3, 4. What we're gonna do is we're gonna say that this is x sub 1, y sub 1, x sub 2, y sub 2. Okay, so then we're gonna plug in these values in here to get the distance. If you want, try and pause the video and try and do it for yourself. What would be the distance from these 2 points, or the radius of the circle? How would you do this? So here, d is equal to square root of, right? Well, what's my x sub 2? It's 3 minus, right? 3 minus, my x sub 1 is -1 squared, right? Let me zoom in a little bit. Plus y sub 2, which is 4, minus y sub 1. My y sub 1 is 2 squared. So then I have d is equal to square root of 3 minus a minus 1. This becomes 3 plus 1 squared plus 2 squared. So that's d is equal to 4 squared plus 2 squared. So the distance is 16 plus 4, and that's equal to square root of 20. Okay. Notice that this value of d is the radius of our circle. Right? So instead of writing d as a variable over here, you could have used r. That would have been fine. But notice that this square root 20, we know that r is equal to square root 20. So we're going to use that r equals square root 20 into our standard form of a circle, right? And by definition, the center of your circle is represented as h comma k, right? So here, what is our h and what is our k? Here, the center of our circle is right here. It's -1, 2. So this will be -1, 2. So we know our h is equal to -1, our k is equal to 2, and our r is equal to square root 20. And the idea is we're going to use these 3 values over here for the equation of the circle. That's here. It's going to be x minus h squared plus y minus k squared equals r squared. So then here I just have x minus a minus 1 plus y minus 2 squared equals square root of 20, the whole thing squared, right? Because here my h is -1, my k is 2, and my r is square root 20. So I need to take that square root 20 and I need to square it. But then just to simplify it here, this is going to be x plus 1 squared plus y minus 2 squared equals 20. And this represents the equation of our circle over here. Okay, done. That took a lot longer than I thought. 29 minutes, holy moly. But hopefully this lesson was all right. What I'll do is on Delta Math and on the problem set, I'll have some questions for you to practice, and we will definitely go over this in class together when we see each other very soon. Okay, I hope the lesson was good. Make sure your notes are nice and neat. Enjoy your day. I'll see you.